Good evening. In today's class, we'll be discussing about the salivary formation and its secretion. Right. Before we go to the secretion and formation of saliva, what are the different salivary glands? So we have three major salivary glands, right? And these three major salivary glands are parotid, submandibular, and sublingual, isn't it? So these are the three main salivary glands, and the largest amongst these is parotid. So this is the largest, parotid is the largest, and sublingual is the smallest, isn't it? Sublingual is the smallest. Another difference that we need to notice is that parotid is pure serous. Submandibular is mixed with a dominant serous component. Sublingual again is mixed but with a dominant mucus component, right? So you can say that sublingual is mixed with a mucus secretion, submandibular is mixed but with a dominant serous secretion, and parotid is pure serous, right? Another important thing that we need to notice here is that in the resting state, submandibular gland, it forms maximum saliva, or you can say dominant saliva is produced, a dominant salivary secreting gland in resting state. So maximum saliva in resting state is produced by submandibular gland, but in stimulated state, so maximum salivary secretion in stimulation or after stimulation. So once you stimulate, once you provide the stimulation, then maximum salivary secretion would be from parotid. In the resting state, it would be from submandibular gland, right? So these are some of the differences. Another difference is that the parasympathetic supply for submandibular and sublingual gland is from facial nerve. That is the 7th cranial nerve, right? And for the submandibular, for the parotid gland, the parasympathetic supply is from the 9th cranial nerve, that is glossopharyngeal nerve, right? So it is from the glossopharyngeal nerve. So these are some of the key differences between these major salivary glands. Since today's class is not about these glands, it is about the saliva formation and secretion. So this is just a brief introduction about the different types of salivary glands, right? So just like these different salivary glands, is it okay now? I hope it's working now, right? So I guess before the network was disconnected, I was telling you about the different types of parasympathetic innervation. The parasympathetic innervation for these glands, right? So the parasympathetic innervation for these glands, for the submandibular and the sublingual gland, is from facial nerve, right? Facial nerve, which is the 7th cranial nerve, isn't it? It is the 7th cranial nerve. And for the parotid gland, it is from the 9th cranial nerve, which is glossopharyngeal. So these are the two parasympathetic supply of the parotid and the submandibular and sublingual glands. So apart from these, as you would have noticed, these glands they are either serous or they are mucinous, right? So there are two different types of secretory units. So there are two different types of secretory units. And what are these two different types? A serous and a mucinous. So the serous secretory unit is spherical. It is spherical, whereas the mucinous secretory unit is oval, right? And apart from this, the number of cells in each of these or in either of these is same. It is 8 to 12 per unit, right? The shape of the cell is also similar. The shape of the cell is also similar and it's pyramidal with clefts at the base, right? It is pyramidal, isn't it? The difference is in the shape of the nucleus. The difference is in the shape of the nucleus. So how is the shape of the nucleus? The shape of the nucleus resembles the secretory unit. So in case of serous unit, here the secretory unit is spherical. So the nucleus is spherical. It is spherical in the serous secretory unit, and it is oval in the mucus secretory unit, right? So this is the shape of the nucleus resembles that of the secretory unit. So when you look at the cell of the serous unit, it appears like this, right? It is pyramidal with a spherical nucleus, and it has transport vesicles at its apex which look like pearls, and these are known as zymogen granules, right? These are known as zymogen granules. So basically zymogen granules are transport vesicles which are containing proteins, and they are seen in these serous secretory unit, or they are seen in the serous secretory cells, right? Whereas when you look at the mucinous cells, their nucleus is flattened or it is oval, and their cytoplasm is more or less filled with mucin. It is filled with mucin. So this mucin applies the pressure all around it, and this pressure flattens the nucleus. Pressure also applies an outward force on the plasma membrane, isn't it? So what happens is that in case of serous unit, let's say this is the serous unit. In case of serous unit, you would notice intercellular spaces between the cells, right? There would be intercellular spaces between the cells. But in case of mucus secreting cells, in case of mucinous secretory units, since an outward force is applied by the mucin, these intercellular spaces, they are absent, right? The intercellular spaces are absent. Clear? So these are the few differences between the serous and mucinous units. I hope it is clear. क्या ये सबको समझ में आ रहा है? कहीं कोई डाउट है तो आप पूछ सकते हो. कहीं कोई डाउट है तो आप पूछ सकते हो. Is it clear? The difference between the different types of salivary glands and different types of secretory units. So after that, I'll briefly tell you about the composition of saliva. So composition of saliva, mainly it is made up of water, right? So water is the main component. Approximately 98% of saliva is water. Apart from it, what else do we have in saliva? Inorganic and organic. So these are the solids in the saliva, inorganic and the organic. So let's first talk about the inorganic component. So what is the inorganic component of saliva? You can divide it into major and minor ions, right? We can divide it into major and minor ions. So what are the major ions? The major ions, we have just 4 major ions, right? Sodium, chloride, potassium, and bicarbonate. So these are the major ions found in saliva. Clear? And bicarbonate has a role in buffering. It balances the pH of saliva, right? So it is the primary buffer of saliva. Apart from it, we also have some other buffer, that is the secondary buffer. So what are the minor ions? Minor ions, whatever you can remember that you would have studied in saliva, like calcium, magnesium, right, phosphate, iodide, thiocyanate, all these are minor ions. Fluoride, so all these are minor ions, isn't it? All these are minor ions. And amongst this phosphate, this is the secondary buffer. Calcium, fluoride, phosphate, these all help in mineralization of the tooth, isn't it? They help in the maturation of enamel. So these are the major and minor ions. Apart from these, we also have certain organic components in the saliva, isn't it? So what are the organic, or what is the organic composition of saliva? So what is the organic content of saliva? There are certain enzymes. So which enzymes are present in saliva? Salivary amylase. So salivary amylase, it helps by digesting starch, right? It helps by digesting starch and converts it into maltose, isn't it? It converts into maltose. So the secondary enzyme is maltase, which digests maltose and converts it into glucose. Third enzyme is lipase, salivary lipase, and since it is mainly secreted by the sublingual gland, it is often called lingual lipase. It is often called lingual lipase, and this lingual lipase, what it will do, it will digest the, as the name suggests, lipid molecules. It will convert them into fatty acids, isn't it? So these are some of the digestive enzymes that are found in salivary gland, or that are found in the saliva. Apart from these, there are certain other enzymes as well, like lysozyme, lactoferrin, so both lysozyme and lactoferrin are antibacterial or bactericidal. These are antibacterial enzymes, right? Apart from this, we also have a stabilizing enzyme, steatherin. So what does steatherin do? It stabilizes calcium and phosphate in saliva. So what it means is that it prevents precipitation of these ions. It prevents precipitation of these ions, right? So they stay dissolved in the saliva, right? So these are some of the enzymes that are found in saliva. Apart from these, what other organic molecules are found in saliva? See, saliva is not just a secretory substance, right? It can also be considered as an excretory substance. So when you say excretory, it often has excretory molecules in it. So excretory molecules, that is waste product like urea and ammonia. So uric acid, right? So these are the excretory products that are found in saliva. So amongst these excretory products, urea and ammonia, they may also act as buffers, right? So they may also act as buffers. So the primary buffer is bicarbonate, secondary buffer is phosphate, HPO4 minus, and after those urea and ammonia may also act as buffers, right? So these are the excretory products that are found in saliva. Apart from this, immunoglobulin is found in saliva. Immunoglobulin A, that is secretory. Immunoglobulin is found in saliva. What else is found in saliva? Growth factors. So growth factors like epidermal growth factor or epithelial growth factor, EGF, neural growth factor or nerve growth factor, that is also found in saliva, right? So these are a couple of growth factors that are found in saliva, right? So these are the different organic and inorganic molecules that are found in saliva. So apart from this, the mucinous secretory unit, what does it secrete? It secretes mucin. So mucin is also found in saliva and it helps in lubrication, right? It helps in lubrication. So I hope I am clear about these components, right? Is there any doubt? If you have any doubt, you can ask me, right? So there are different enzymes, growth factors, mucin hota hai, immunoglobulins hote hain, right? And then there are some excretory products as well. Clear? So this was about the composition of saliva. Now let's go into the formation of saliva. अब हम formation की तरफ चलते हैं. तो formation of saliva वो कैसे होता है? Formation of saliva. तो saliva का जैसा अभी हमने पढ़ा, there are two components, a solid and a liquid. तो liquid component यानी water, that is the main component and it forms 98% of the saliva. Remaining solid, they are just 2% and they compose of organic and inorganic, isn't it? So how are these components produced? Let's say this is a secretory cell, a serous secretory cell, right? So these serous secretory cells, they have rough endoplasmic reticulum, isn't it? They have rough endoplasmic reticulum. Then they have Golgi complex, isn't it? They have Golgi complex. So let's say this is the Golgi complex and this is the rough endoplasmic reticulum. So as far as the solid part is concerned, it's quite easy, right? The inorganic component is derived from the blood vessels. These are the blood vessels, right? These are the blood vessels and they are the source of inorganic component, right? So how is the organic component created? Rough endoplasmic reticulum, it synthesizes proteins, right? From here, these proteins, they are transported to Golgi complex where they are modified, right? So these proteins, they are transported to Golgi complex where they are modified. Finally, these modified proteins, they are packed into vesicles. They are packed into vesicles which are known as transport vesicles. Transport vesicles. So after Golgi complex, these proteins are packed into transport vesicles and these transport vesicles, they move and fuse with the plasma membrane at the apex. From there, they are ejected into the lumen, right? They are ejected into the lumen of the secretory unit, right? So what happens is, and then these transport vesicles, they move and fuse with the plasma membrane at the apex, and from there they are ejected into the lumen, right? Lumen of the secretory unit. Clear? So that's how the solid component of the saliva is formed. As far as the mucin is concerned, so when you have the mucinous cell, the mucin, as I have told you, already fills the entire, cytoplasmic space of the cell, right? So from here it is directly expelled into the lumen. It is again synthesized in the cell and it is expelled into the lumen. So there is not much about the solid component of the saliva. But as far as its liquid component, that is the water, is concerned, that is the main thing from where questions are sometimes made, right? So how is the water component of saliva formed? So let's say this is a secretory cell. It might be mucinous, it might be serous. It doesn't matter because the mechanism of formation of the liquid component is same, right? So in the base of these cells, we have numerous blood vessels. And these folds, they are approximately 0.5 microns deep. So we have numerous blood vessels associated with these folds. And salivary gland is one gland that has exclusive neural stimulation, right? There is no hormonal stimulation. There is no other stimulation. There is exclusive neural stimulation. You think about food, you look at your favorite dish, you taste your favorite dish, and saliva will start forming instantaneously, isn't it? So it is exclusively neural stimulation, right? It is exclusively neural stimulation. So what happens once the salivary gland is stimulated? And when we say neural stimulation, we just discussed that there are parasympathetic supply to both parotid, submandibular and sublingual glands. So either it is parasympathetic or it is sympathetic, right? And I have told you about the parasympathetic supply. Why? Because it is mainly the parasympathetic supply which stimulates the salivary secretion. The sympathetic supply, it suppresses the salivary secretion, right? So basically it is the parasympathetic stimulation which leads to saliva formation and its secretion. So parasympathetic supply, as I have told you, it is 8th and 9th cranial nerve. It is from 8th and 9th cranial nerve, the facial and the glossopharyngeal nerve, right? So what happens is that upon stimulation, the rough endoplasmic reticulum, it expels calcium into the cytoplasm, right? So when the salivary gland, it receives any stimulation, be it sight, be it smell, be it a thought of your favorite food, what happens is these cells are stimulated, so the calcium from the rough endoplasmic reticulum is secreted into the cytoplasm. Now this cytoplasm becomes positively charged, isn't it? And unless this charge is balanced, this cell will die, right? It will die. So this charge needs to be balanced, and we know that intercellular space is rich in potassium and extracellular space is rich in sodium, isn't it? So what does the cell do next? It has to balance the positive charge which has increased in the cytoplasm. So what it does is it opens the sodium potassium exchanger, right? So two sodiums are pumped in exchange of two sodiums are pumped in exchange of 3 potassium. So there is a total loss of positive charge from the cell, isn't it? 3 पोटेशियम बाहर दे दिए, 2 सोडियम अंदर ले लिए, तो सोडियम तो 2 ही अंदर आए, पोटेशियम हमने 3 बाहर भेज दिए, तो टोटल पॉजिटिव चार्ज सेल का कम होने लग गया, isn't it? So this is the sodium potassium exchanger. Apart from this, there is other channel as well, sodium potassium chloride channel. Through this channel, chloride, which is also present in the extracellular fluid, is pumped in. So chloride is pumped in, right? So what has happened till now? What has happened till now? First of all, there was stimulation. What kind of stimulation? It is always a neural stimulation. And when we say neural stimulation, it is parasympathetic, right? So upon neural stimulation, what happened next? Calcium released from rough endoplasmic reticulum, isn't it? Calcium was released from rough endoplasmic reticulum into the cytoplasm, right? So calcium was released in the cytoplasm. So the cytoplasm becomes increasingly positive. It becomes positively charged, and unless this charge is balanced, the cell, it will undergo apoptosis, isn't it? it will die. So what happens next is cell pumps out 3 potassium in exchange of 2 sodium, and this pump is called sodium potassium exchanger, right? So sodium potassium exchanger. So as you can see, 3 potassiums are exchanged for 2 sodium. So a positive charge, it goes down. Apart from this, chloride is pumped into the cell from extracellular fluid, just like sodium, isn't it? So this is happening via the sodium potassium chloride channel, right? So this has happened so far. So after these steps, what has happened? After these steps, what has happened? These are the blood vessels. In the intercellular space, we have, intracellular space, in the cytoplasm, we have calcium, we have chloride, and some of sodium also came in, right? From here, potassium was pumped out, isn't it? And chloride was taken in. So do you think that the positive charge that increased inside the cell is now shifted to the extracellular fluid? So this extra positive charge is now shifted in the extracellular fluid with the expelling of or the exchange of sodium and potassium and endocytosis of chloride, isn't it? So a total positive charge is now shifted towards the extracellular space. अब extracellular space में ज़्यादा positive charge हो गया क्योंकि हमने ज़्यादा potassium भी बाहर भेज दिया और हमने chloride भी cell के अंदर डाल दिया, तो बाहर की तरफ positive charge ज़्यादा बढ़ गया, right? In this meantime, when all of this was happening, the rough endoplasmic reticulum, it stabilizes and the calcium is drawn back inside the rough endoplasmic reticulum. तो इस सब के दौरान क्या हुआ? रफ एंडोप्लाज्मिक रेटिकुलम वो स्टेबल हो गया और जो कैल्शियम था वो वापस से रफ एंडोप्लाज्मिक रेटिकुलम में चला गया. तो अब साइटोप्लाज्म में कैल्शियम हट गया मतलब पॉजिटिव चार्ज खत्म हो गया. सो एज सून एज पॉजिटिव चार्ज मूव्स बैक इनटू द रफ एंडोप्लाज्मिक रेटिकुलम, नाउ देयर इज अ टोटल नेगेटिव चार्ज विद इन द सेल. तो अब प्रॉब्लम वापस वहीं आ गई. पहले पॉजिटिव ज्यादा था, अब नेगेटिव ज्यादा हो गया है. सो अगेन द सेल कैन डाई and we need to balance this negative charge. So how does the cell balance this negative charge? So remember that inside the cell there is excess of negative charge, isn't it? So inside the cell at this moment there is excess of negative charge and in the extracellular space there is excess of positive charge, right? तो अभी क्या हुआ? आगे हम देखें अगर तो फिफ्थ स्टेप में after chloride was pumped in, we have studied in the 4 steps that chloride is pumped in, right? So the charge has been balanced inside the cell, but a net positive charge is present in extracellular fluid. Also, RER stabilizes and calcium moves back inside RER. So the cytoplasm it becomes negatively charged. So now the cytoplasm or the intracellular space is negatively charged and extracellular space is positively charged and they need to balance their charges, right? So what they do? We need to balance the charges. So to balance the charge, what happens is, this is the cell again, right? These are the blood vessels. The calcium from the cell is pumped out by this cell into the lumen, right? So chloride. This chloride is pumped out of this cell into the lumen of the secretory unit. तो एक क्लोराइड कहाँ गया? ल्यूमेन में आ गया. दिस इज द ल्यूमेन. right? This is the lumen. So the chloride is pumped into the lumen, and as I told you, there is excess of positive charge in the extracellular space, and extracellular space is rich in sodium. So obviously it will remove its sodium so that its charge is balanced. So the extracellular fluid, this extracellular fluid here, it also expels the sodium into the lumen. Extracellular fluid, it expels sodium into the lumen. So now the charge in extracellular fluid is also balanced, and we have sodium and chloride in the lumen, isn't it? So what happens next? Chloride is pumped out by the cell into lumen, and sodium is pumped into the lumen by ECF. So sodium is provided in the lumen by ECF, and chloride is provided in the lumen by the cell. So now in this lumen we have sodium and chloride. So what do we have in lumen? In lumen we have sodium and chloride, and as we know, NaCl, namak, salt, it is hypertonic, right? Pure salt, it would create a hypertonic environment, isn't it? So with the presence of NaCl, hypertonic environment is created in the lumen. So this is the lumen. This is the secretory cell, and we have sodium chloride in the lumen. So now a hypertonic environment is created in the lumen. So what it will do is, it will draw water from the cell, right? It will draw water from the cell. So water will start accumulating in the lumen, isn't it? Water will start accumulating in the lumen, and if the cell keeps on losing water, it will become dehydrated, and it will die, isn't it? So to stay alive, what does the cell do? It has so many blood vessels associated with it, isn't it? So when the cell loses water into the lumen, it draws water from these blood vessels, isn't it? It will draw water from these numerous blood vessels associated with its base. So water to the cell is transported from these blood vessels, and from this cell the water is transported into the lumen. So water moves. So water moves from blood vessels into cell, and from cell into lumen, right? So this is the path of the water from blood vessels to cell to lumen. And how long do you think this movement will continue? So this movement will continue, this movement of water. So water moves into lumen till lumen becomes isotonic, right? So till the environment in the lumen becomes isotonic. That is, the osmolarity of the lumen and of the cell is same. So it becomes isotonic. So the composition of initially or the first from saliva is same as that of plasma, right? Sodium and chloride composition, the sodium and chloride concentration or composition of first formed saliva is same as plasma, isn't it? It is same as that of plasma. I hope this is clear. क्या इस स्टेप में किसी को कोई भी डाउट है? सबसे पहले न्यूरल स्टिमुलेशन, रफ एंडोप्लाज्मिक रेटिकुलम स्टिमुलेट होती है, कैल्शियम बाहर सीक्रेट होता है साइटोप्लाज्म में, कैल्शियम की वजह से पॉजिटिव चार्ज बढ़ गया तो सोडियम अंदर और पोटेशियम एक्स्ट्रासेल्युलर फ्लूइड में पंप होता है, साथ में क्लोराइड भी सेल के अंदर आता है। सेल के अंदर क्लोराइड आ गया, अब इसी टाइम पे रफ एंडोप्लाज्मिक रेटिकुलम स्टेबलाइज होता है, कैल्शियम को विड्रॉ कर लेता है, तो सेल के अंदर नेगेटिव चार्ज बढ़ गया और बाहर पॉजिटिव चार्ज ज्यादा है, क्योंकि हमने बाहर से क्लोराइड सेल में भी डाल दिया, साथ में पॉजिटिव चार्ज बाहर भी भेज दिया था। तो एक्स्ट्रा सेल्यूलर फ्लूइड से तो सोडियम ल्यूमेन में आ गया और सेल से क्लोराइड ल्यूमेन में आ गया। ल्यूमेन में क्या बन गया? सॉल्ट, NaCl. So it will draw water till the environment becomes isotonic. So it will draw water from lumen, it will draw water from cell, and cell will draw water from the blood vessels, from these numerous blood vessels that are associated with it, isn't it? Till the environment in lumen becomes isotonic. So this first form saliva, it has same concentration of sodium and chloride as that in plasma. Clear? So first form saliva कैसा isotonic है? इसकी concentration plasma के जैसी ही है। इसके बाद क्या होगा? Let's say this is the secretory unit. So associated with the secretory unit, this is the secretory unit, is the intercalated duct. This is the intercalated duct. Numerous intercalated ducts from other different glands, they'll meet to form a large striated duct. So numerous intercalated ducts meet to form striated duct, and similarly numerous striated ducts, they will meet to form the main excretory duct, right? So the smallest duct associated with the secretory unit is the intercalated duct. Several intercalated ducts from adjacent secretory units, they will join to form the striated duct, and several striated ducts will join to form the main excretory duct of the salivary gland, right? For example, Stensen's duct is the main excretory duct of the carotid gland, isn't it? So that's how these ducts of the salivary gland are there, right? So what are the roles of these ducts in the salivary formation and secretion? So as I told you that water and the solid component of saliva are synthesized by these secretory units, isn't it? The cells present in the secretory units. But the intercalated duct, it also has a role, isn't it? It secretes or it forms lactoferrin and lysozyme. So it secretes lysozyme and lactoferrin into the saliva. Next, when this first form saliva reaches striated duct, then this saliva is modified, right? This saliva is modified. So modification of saliva takes place in striated ducts. So why are these striated ducts called striated ducts? Because the cells in these striated ducts, they have numerous and deep striations at their base. So as you can see, it has deep striations at its base, and they are numerous. Basically, these striations, they increase area of the cell for exchange, isn't it? They increase the surface area of the cell for exchange. Now the fluid or the first form saliva is flowing through the striated duct, isn't it? So what happens when the saliva passes through the striated duct? This first form saliva is rich in sodium and chloride. So what the striated duct cells do, they reabsorb sodium and chloride, isn't it? They reabsorb sodium and chloride, and they put it back into the bloodstream, right? They put it back into the bloodstream. So sodium and chloride are reabsorbed. Sodium and chloride are reabsorbed from the saliva, and then they are secreted back into the bloodstream, and they will provide potassium and bicarbonate. So potassium and bicarbonate are provided by these striated ducts. So potassium and bicarbonate are secreted into the saliva, right? Potassium and bicarbonate are secreted into the saliva by these striated duct cells, right? So sodium and chloride is removed, potassium and bicarbonate are added. So now after modification, this saliva, since it has low sodium and chloride content, is called hypotonic, right? So the modified saliva, it has low sodium and chloride, so it is called hypotonic. So the final saliva that is secreted into the oral cavity is hypotonic, right? The final saliva secreted in oral cavity, that is hypotonic, right? And the first formed saliva, the saliva that formed in the lumen of the secretory unit, that is isotonic. Clear? So the saliva in the oral cavity is hypotonic. The saliva that forms in the secretory unit is isotonic. And the difference is modification. Modification takes place in striated ducts. Clear? The role of excretory duct is just transporting saliva from striated duct into the oral cavity. So it does not modify saliva, does not add anything, it does not remove anything. And these striated duct cells, they are impervious to water. They are impervious to water, and that is why when sodium and chloride are reabsorbed from the saliva, from the first form saliva, the water does not return. It does not. The water is not reabsorbed, right? Only the ions are reabsorbed. Clear? Neither water is secreted. So neither it is secreted nor it is reabsorbed. It just stays the volume of the saliva stays as it is when it is first formed, right? So only there is an exchange of ions in this striated duct. There is no exchange of water. तो ये तो था फॉर्मेशन के बारे में. सिक्रीशन के बारे में अब मैंने क्या बताया? सिक्रीशन के बारे में मैंने आपको बताया कि there are two controls, parasympathetic and sympathetic, right? And mainly it is the parasympathetic control which is from 7th and 9th cranial nerve. तो ये हमेशा ध्यान रखना, parasympathetic control is the main control which helps in salivary secretion, 7th and 9th cranial nerve, glossopharyngeal and facial. Sympathetic का क्या रोल है? Sympathetic basically suppresses salivary secretion and formation. तो सिंपैथेटिक का रोल डोमिनेंट नहीं है, उसका एकदम एक्टिव रोल नहीं है, राइट? एक्टिव रोल किसका है? पैरासिम्पैथेटिक का. इट हेल्प्स इन दी secretion or in the formation of saliva. Also, salivary secretion, that is the only secretion which is purely neural, right? Sight or thought or smell or taste, all these will stimulate salivary secretion, isn't it? तो ये सारे के सारे कैसे हैं? ये सारे के सारे न्यूरल स्टिमुलस हैं, isn't it? इसमें कोई हार्मोनल स्टिमुलस नहीं है, इसमें कोई और केमिकल स्टिमुलस नहीं है, कोई फिजिकल स्टिमुलस नहीं है, ऐसा कुछ नहीं है. ये सब न्यूरल स्टिमुलस है, राइट? अब लास्ट में what will happen to the content of or to the concentration of sodium chloride, potassium and bicarbonate with varying salivary secretion. तो अगर salivary secretion वेरी करता है तो इनकी concentration पे क्या इफेक्ट पड़ेगा, राइट? तो पहला एग्जांपल ले लेते हैं. increased salivary secretion. So when the salivary secretion increases abruptly, right? Salivary secretion increases abruptly. So when would that happen? जब आपने कोई अच्छी सी चीज खा ली है, एकदम से कोई बढ़िया सी चीज आपने देख ली है, एकदम से आपके मुंह में सलाइवा ही सलाइवा हो गया, राइट? या कोई खट्टी चीज खा ली है, कोई ऐसी चीज खा ली है which again stimulates salivary secretion, isn't it? Oral environment acidic हो गया है, oral environment, acidic ho gaya, and you need buffering. So again, salivary secretion will increase. So under any condition where salivary secretion suddenly increases, there is an increased parasympathetic stimulation, है ना? So there is an increased parasympathetic stimulation. तो उस केस में क्या होगा? Rapid salivary formation होगा या rapid salivary secretion होगा, isn't it? There would be a rapid salivary secretion. So when there is a rapid salivary secretion, what will happen is striated the sodium and chloride, they need to be reabsorbed, and potassium and bicarbonate, they need to be secreted. This is the, let's say this here is the saliva, isn't it? So when the saliva is forming rapidly, it is moving rapidly, do you think we have sufficient time for sodium and chloride reabsorption? Do you think we have sufficient time for sodium and chloride reabsorption? And the answer is no, we do not have sufficient time for their reabsorption, isn't it? But since it is an emergency, maybe, or maybe there is some other reason because of which salivary secretion suddenly increased, do you think bicarbonate might be needed? Yes, it might be needed, isn't it? आप कुछ खा रहे हो या मुंह का एनवायरनमेंट अचानक से एसिडिक हो गया किसी भी वजह से, so to balance that pH we need bicarbonate. So its secretion, do you think it will increase? Yes, its secretion will increase. So sodium and chloride, their reabsorption has reduced, bicarbonate secretion has increased, and potassium is not very important, right? It does not have any active role. So since it does not have any active role, do you think the salivary gland would pay any attention to this ion to increase its secretion? And again the answer would be no, isn't it? So the secretion of potassium does not increase. So again its concentration would remain low. Bicarbonate's concentration increases because we need bicarbonate in the saliva, isn't it? Sodium and chloride, they are not being actively resorbed, so their concentration also increases, isn't it? So when there is a rapid salivary flow, the concentration of potassium decreases and the concentration of bicarbonate, sodium and chloride increases, isn't it? Now, contrary to this, if there is a reduced salivary flow, if there is a stagnant condition, if there is a resting condition, in the resting condition when there is low salivary flow, the salivary flow is very low, isn't it? What will happen at that time when the salivary flow is very low? This is the saliva, and here we have sodium and chloride, right? Here we have potassium and bicarbonate. Now since the salivary flow is very low, we have sufficient time for reabsorption of chloride and sodium both, isn't it? And we have sufficient time to secrete potassium in exchange of sodium. But do we need to waste this bicarbonate since there is no need to balance any pH at the moment, right? The salivary secretion is very low. There is no demand for this salivary secretion. So do we need to waste the bicarbonate at such a moment? And the answer would be no. So its secretion is low. The bicarbonate secretion is low as compared to the other condition, right? So what happens is sodium and chloride are actively being absorbed, so their concentration in saliva decreases. Bicarbonate is not being secreted actively, so its concentration also drops. Potassium is being secreted at its normal pace, so obviously its concentration increases. So when there is a reduced salivary flow, what will happen? Potassium will increase, bicarbonate, chloride and sodium, they will reduce, their concentration will reduce. So this was all about the formation and secretion of saliva. If you have any doubt, you can ask me. Now. If not, then maybe we can solve some MCQs, right? So let's try to solve some MCQs based on the discussion that we just had. So which of the following statements is true regarding the primary saliva secreted by the acinar cells? So Utkarsh, please also try to answer these. Potassium increases, sodium decreases all times. Yes, potassium and sodium decreases all time. No, it does not happen like that. Potassium increases and sodium decreases all times. If there is a rapid salivary flow, sodium will increase, potassium will decrease. If there is a reduced salivary flow, then potassium will increase and sodium will decrease, right? The salivary flow has to be slow for that sodium to be reabsorbed. If it is flowing rapidly, then we don't have sufficient time for reabsorption of sodium, right? So it is not that potassium always increases and sodium always decreases. Sodium decreases, potassium increases only when there is a reduced salivary flow. If there is a rapid salivary flow, sodium will increase, potassium will decrease. Is it clear? So which of the following statement is true regarding the primary saliva secreted by the acinar cells? It is hypertonic. It contains mostly mucus and immunoglobulin A. It has a similar electrolyte composition to plasma, and it is hypotonic due to ductal reabsorption. So obviously it is not hypotonic, isn't it? Mucus के बारे में हमने कोई बात नहीं की. It does not contain mostly mucus. Hypotonic भी नहीं है. Obviously it is isotonic. So similar electrolyte composition, that means it is isotonic. So option C is correct. Very good. Whoever answered Utkarsh and whoever answered option C, right? So let's go to the next question. Modification of saliva from isotonic to hypotonic occurs primarily in which ductal segment? तो जो modification हुआ isotonic से hypotonic का, sodium chloride reabsorbed, potassium bicarbonate secreted, ये किधर हो रहा है? Options है intercalated duct, excretory duct, interlobular duct and striated duct. So where do you think this is happening? Modification of saliva ये कहाँ पर हुआ? उत्कर्ष, अभी अभी हमने पढ़ा किधर हुआ है, और बाकी बच्चे किधर हुआ ये modification of saliva? It is happening in striated duct, isn't it? It is happening in striated duct. Yes, very good. The correct answer is D. Intercalated duct क्या करती है? Intercalated duct, it secretes lactoferrin and lysozyme, isn't it? So let's go to the third question. Which cranial nerve primarily supplies the submandibular gland? So which nerve is supplying the submandibular gland? ये हमने डिस्कस किया है स्टार्टिंग में, राइट? It is the fifth nerve or the seventh or the ninth or the 10th. Which nerve supplies submandibular gland? अगर सबमैंडिबुलर की जगह यहाँ पर सबलिंगुअल होता तो भी आंसर सेम ही होता, राइट? एंड व्हाट इज द करेक्ट आंसर? इज इट 5, 7, 9 or 10? एंड द करेक्ट आंसर इज cranial nerve 7, that is facial nerve, isn't it? Right? So let's go to the next question. During parasympathetic stimulation, what type of saliva is predominantly secreted? उत्कर्ष इधर गलत हो गया. C यानी कि ग्लोसोफेरिंजियल नर्व नहीं है, फेशियल नर्व है. ग्लोसोफेरिंजियल नर्व सप्लाइज पैरोटिड ग्लैंड, राइट? जो 9th क्रेनियल नर्व है ग्लोसोफेरिंजियल, इट सप्लाइज पैरोटिड ग्लैंड, राइट? और फेशियल नर्व जो है वो सबमैंडिबुलर और सबलिंगुअल ग्लैंड को सप्लाई करती है. तो धीरे धीरे याद हो जाएगा, डोंट वरी. During parasympathetic stimulation, what type of saliva is predominantly secreted? So parasympathetic stimulation है, right? What type of saliva would be secreted? So when there is an increased salivary flow, what type of saliva would be secreted? Watery and enzyme rich, mucin rich, thick and viscous, protein poor and hypertonic. तो इसमें हम क्या कह सकते हैं? हाइपरटोनिक सलाइवा तो कभी भी नहीं होता. Either it is isotonic or it can be hypertonic. It cannot be hypertonic, right? Thick and viscous, rich in mucin. Both of these options are talking about the same thing. It will be thick and viscous when it is mucinous, right? When there is more of mucin, it will become thick and viscous. So we can easily rule out option B and C. Obviously, when there is an increased stimulation, more of saliva will form, more of water will be drawn, right? So it will become more watery and enzyme rich, isn't it? Parasympathetic basically it stimulates saliva secretion, isn't it? Protein secretion भी, water secretion भी, या water formation भी, सब कुछ ये बढ़ाएगा, right? So option A is the correct answer. Very good, Utkarsh and AJ. So next question, which ion is actively secreted into saliva during ductal modification? So actively secreted into saliva during ductal modification. So where is ductal modification taking place? At the striated duct, isn't it? Striated duct में हो रहा है ना ductal modification. तो कौन सा आयन इसमें से actively secrete हो रहा है? Sodium, chloride, potassium या calcium? So which is actively secreted? Which is actively secreted? Secreted means it is being dumped into saliva. Reabsorbed means it is being taken from saliva into the bloodstream. और यहाँ पर क्या हुआ? ब्लड स्ट्रीम से सलाइवा में डाल रहे हैं. तो करेक्ट आंसर क्या होगा इसका? इसका आंसर होगा potassium, isn't it? Potassium and bicarbonate are secreted into the saliva. Sodium and chloride are reabsorbed, isn't it? So option C, that is potassium, is the correct answer. Is it clear? Sodium and chloride are reabsorbed. Very good. Which of the following statements about salivary gland acini is incorrect? So which is incorrect? Serous acini secrete watery, enzyme-rich fluid. Mucous acini produce thick, glycoprotein-rich saliva. Mixed acini are seen in parotid gland, and mucous cells have flattened, basally located nuclei. So mucous cells have flattened, basally located nuclei. That is correct. Mucous acini produce thick glycoprotein-rich saliva. Basically, glycoprotein or mucin, it's one and the same thing, right? So mucous acini produce thick mucinous saliva or glycoprotein-rich saliva. It's one and the same thing. So option B is also correct. Option A, serous acini secrete watery, enzyme-rich fluid. That is also correct. They produce proteins, basically enzymes and other things, right? And it is watery. So option A is correct, B is correct, and D is correct. So which is incorrect? It is the option C. That is mixed acini seen in parotid gland, because parotid gland is pure serous, isn't it? It is pure serous. Can you tell me which other salivary gland is pure serous? Which other salivary gland is pure serous? Hint, it is a minor salivary gland, right? It is a minor salivary gland. So this is your hint. So think about the gland which is pure serous apart from parotid till we complete this question here, right? The enzyme responsible for initiating starch digestion in mouth is. तो इनमें से कौन सा एंजाइम है जो कि स्टार्च को डाइजेस्ट करेगा? सिंपल है, हमने वहां पर लिखा था, राइट? पेप्सिन, ट्रिप्सिन, लिपेज, अमाइलेज. तो आंसर क्या है इसका करेक्ट? अमाइलेज, isn't it? Salivary amylase. It is also known as ptyalin, right? The salivary amylase is also known as ptyalin. Next, which of the following is least likely to stimulate salivary secretion? So least likely to stimulate salivary secretion. What are the options? Fear and anxiety. What are the options? Fear and anxiety, smell of food, chewing food and acidic food on tongue. तो क्या लग रहा है इनमें से कौन सा होगा? अच्छा, उत्कर्ष ने ऑप्शन डी जो है ये क्वेश्चन 7 का आंसर दिया है, राइट? So which of the following is least likely to stimulate salivary secretion? And the options are fear and anxiety, smell of food, chewing food and acidic food on tongue. तो क्या लगता है इनमें से कौन सा ऑप्शन सही होगा? acidic food on tongue, acidic food on tongue, obviously it will need to be neutralized the acidity, तो buffer चाहिए, bicarbonate चाहिए, rapid salivary flow होगा, ठीक है. Also acidic food means you can taste the food, tangy flavor. हाँ, very good उत्कर्ष. Question 8 का option A, fear and anxiety, that is sympathetic stimulation, isn't it? Option A is it translates into sympathetic stimulation, and sympathetic stimulation, it suppresses salivary secretion, it does not stimulate salivary secretion. So option A is correct answer, right? Rest all other they form parasympathetic stimulation, isn't it? Very good. मुझे लगा नहीं था कि कोई इसका सही आंसर देगा, पर बहुत अच्छे, तो इसका मतलब समझ में आता है. That is good. Which of the following best explains why final saliva is hypotonic? तो final saliva hypotonic क्यों है? Right? When sodium and chloride are reabsorbed at the striated duct, water should also get reabsorbed. It should also get reabsorbed, and the fluid in the salivary duct, it should remain isotonic. But that does not happen. Only sodium and chloride is reabsorbed, right? And the fluid becomes isotonic. So why does that happen? That is what this question is asking, right? Options are: duct cells are impermeable to water. Option B, high secretion rate dilutes iron. Option C is reabsorb, and option D is immunoglobulin A binds water molecules. So obviously option D तो बिल्कुल ही हम rule out कर सकते हैं, right? क्योंकि कुछ भी सेंस नहीं बना रहा है. Option C, acinar cells reabsorb sodium. Option C, acinar cells reabsorb sodium. So acinar cells don't reabsorb sodium. They do not reabsorb sodium. The ductal cells reabsorb sodium, and that will be striated duct cells, right? So you can again rule out option C, isn't it, उत्कर्ष? तो option C भी rule out कर दिया हमने, है ना? क्योंकि acinar cells reabsorb नहीं कर रहे, ductal cells reabsorb कर रहे हैं, and that too striated duct cells. Option B, high secretion rate dilutes ions. So however high the secretion rate is, it can only make the saliva isotonic. It cannot keep on secreting fluid till it becomes hypotonic, right? जो ल्यूमेन में हमने देखा वाटर का मूवमेंट हुआ सेल और ब्लड वेसल्स के थ्रू, it can only make this fluid isotonic. This saliva, this primary saliva can never become hypotonic, isn't it? So you can again rule out option B. और हिंट मैंने तुम्हें यहाँ ऑलरेडी दे दिया था, right? We do not have the reabsorption of sodium and chloride. That option we do not have here, right? अगर वो ऑप्शन होता तो हम उसको मार्क कर देते. तो हमारे पास क्या ऑप्शन है? हमारे पास वो ऑप्शन है जो कि हमें खुद से अज्यूम करना पड़ रहा है, या जो कि हमने सेकेंडरी एक तरीके से काम कर रहा है कि सोडियम क्लोराइड तो एब्जॉर्ब हो रहा है, वाटर एब्जॉर्ब नहीं हो रहा है. तो जो एब्जॉर्ब नहीं हो रहा उसको यहाँ पर हमने कंसिडर किया है, राइट? जो डक्टल सेल्स हैं, they are impermeable to water, and since they are impermeable to water, only sodium and chloride is being absorbed. तो ये हमें इनडायरेक्टली अज्यूम करना पड़ रहा है कि जब वाटर के लिए impermeable है बट सोडियम क्लोराइड के लिए तो परमिएबल है, तो सोडियम और क्लोराइड रीअब्सॉर्ब हो रहे हैं, वाटर रीअब्सॉर्ब नहीं हो रहा है, और इस वजह से ये हाइपोटोनिक बन गया है. इज इट क्लियर? ये थोड़ा सा कंफ्यूजिंग कंसेप्ट है, इसलिए मैंने तुम्हारे लिए यहाँ पर ये एमसीक्यू रखा है, राइट? क्योंकि क्या हुआ, अगर यहाँ पर लिखा होता है क्योंकि सोडियम एंड क्लोराइड आर बीइंग रीअब्सॉर्ब्ड, देन इट वुड हैव बीन एन इजी ऑप्शन, इजंट इट? यू कुड हैव डायरेक्टली मार्क्ड इट, यहाँ सोडियम एंड क्लोराइड रीअब्सॉर्ब हुआ, हाइपोटोनिक हो गया. बट देन this is the indirect option where we are saying that sodium and chloride is being reabsorbed, but water is not being reabsorbed because the cells are impervious to water, and that is why due to absorption of sodium and chloride, the remaining saliva, it becomes hypotonic. Is it clear? The buffering action of saliva is mainly due to the presence of, or largely due to the presence of, immunoglobulins, mucin, calcium and bicarbonate. तो ये तो आसान है ना? प्राइमरी बफर तो बाइकार्बोनेट है. इसके बाद कौन है? फॉस्फेट. और इसके भी बाद कौन है? यूरिया. और फिर अमोनिया, राइट? सो दीज आर ऑल दी buffers. This is the primary buffer bicarbonate. Secondary buffer is HPO4. Sorry, HPO4. After bicarbonate, it is HPO4. ये B किसका आंसर दिया है? Mucin is not buffer, right? It is bicarbonate D. Mucin is for lubrication, isn't it? So, which salivary gland produces the largest volume of resting or unstimulated saliva? तो ये भी हमने डिस्कस किया. अनस्टिमुलेटेड या रेस्टिंग सलाइवा सबसे ज्यादा कौन प्रोड्यूस करता है? पैरोटिड और इट्स सबमैंडिबुलर ग्लैंड. तो रेस्टिंग सलाइवा तो सबसे ज्यादा सबमैंडिबुलर ग्लैंड प्रोड्यूस करता है, और स्टिमुलेटेड सलाइवा सबसे ज्यादा पैरोटिड ग्लैंड प्रोड्यूस करता है, राइट? सो द करेक्ट आंसर हियर वुड बी ऑप्शन बी. So don't get confused with parotid gland. Parotid gland is the largest secreting gland when the saliva is being stimulated. Isn't it? Salivary secretion is being stimulated. So stimulated salivary secretion maximum parotid gland से है. Resting salivary secretion maximum submandibular gland से है, right? So this is the last MCQ. Which of the following components in saliva is primarily responsible for antibacterial activity? एंटीबैक्टीरियल एक्टिविटी के लिए इनमें से प्राइमरीली कौन रिस्पॉन्सिबल है? बाइकार्बोनेट है, म्यूसिन है, लाइसोजाइम या अमाइलेज? तो इसका करेक्ट आंसर क्या है? हमने कई बार इसका नाम लिया है, लाइसोजाइम एंड लैक्टोफेरिन. isn't it? Lysozyme and lactoferrin both are secreted by intercalated ducts into the saliva, right? Lysozyme lyses the bacterial cell and lactoferrin bind to the iron, and thus it devoids the bacteria of its nutrition. तो lactoferrin तो क्या करता है? उसका न्यूट्रिशन नहीं मिलने देता बैक्टीरिया को. और lysozyme क्या करता है? It lyses the bacterial cell, right? So lysozyme here is the correct answer. तो हमने पीछे एक क्वेश्चन की बात की थी कि which minor salivary gland is pure serous, isn't it? Which minor salivary gland is pure serous? तो क्वेश्चन तो हमने ये पूछा था कि पैरोटिड के अलावा और कौन सा ग्लैंड है जो कि प्योर सीरस है, और हिंट हमारा था क्या? कि माइनर सलाइवरी ग्लैंड है. तो इसका आंसर क्या है? क्या किसी को पता है कि इसका आंसर क्या है? Von Ebner's gland, right? It is the Von Ebner's gland. क्या पूछना चाह रहे हो? मॉलिक्यूलर CIZAR, व्हाट डज इट मीन? क्या पूछना चाह रहे हो आप? अगर आप मॉलिक्यूलर साइज पूछना चाह रहे हो लाइसोजाइम का तो वो मुझे भी नहीं पता है, ठीक है? बट आई कैन प्रोबेबली फाइंड इट आउट फॉर यू. मॉलिक्यूलर साइज लाइसोजाइम का मैंने वैसे क्वेश्चन कोई देखा तो नहीं है वैसे काफी लंबे समय में, but still we can find it out, right? So one Ebner's gland, that is the pure serous minor salivary gland, and it is associated with circumvallate papillae. Right? It is associated with circumvallate papillae on the dorsal surface of the tongue, right? So this was all about the salivary secretion and formation. अगर आपके और भी कोई डाउट्स हो तो आप पूछ सकते हैं. You can ask me if you have any more doubts. XD का क्या मतलब है उत्कर्ष? एमसीक्यूज कहाँ से करें? एमसीक्यूज के लिए बेस्ट तो पल्स है आपकी, उसमें बहुत सारे एमसीक्यूज हैं, राइट? और काफ़ी समय से पल्स यूज होती आ रही है, इट इज़ रेगुलरली बीइंग अपडेटेड, तो पल्स से आप कर सकते हैं. उसके अलावा डैम्स का मेरे ख्याल से वहां पर भी आपके प्रैक्टिस एमसीक्यूज हैं अवेलेबल डैम्स की ऐप पर, तो आप डैम्स की ऐप पर भी सॉल्व कर सकते हो एमसीक्यूज, राइट। प्रैक्टिस फॉर गवर्नमेंट सिलेक्शन, फॉर गवर्नमेंट जॉब सिलेक्शन अगर आप पूछना चाह रहे हैं, जॉब सिलेक्शन के लिए इफ यू गो थ्रू पल्स, अगर आप पल्स को भी अच्छे से कर लोगे तो भी मोस्ट ऑफ द गवर्नमेंट एग्जाम्स उसी से बनते हैं, पल्स से, राइट। तो इन एनी केस पल्स तो इम्पोर्टेंट है ही है। ओके, रिसेंट ईयर में पल्स से ज़्यादा रिपीट नहीं आ रहे हैं सर जी। एग्जैक्टली, रिसेंट ईयर्स में कहीं पर भी रिपीट नहीं हो रहे, चाहे वो नीट हो, चाहे आपके गवर्नमेंट के हो, बट स्टिल टू फॉर्म योर बेसिक्स, ठीक है, 90% ऑफ द क्वेश्चंस आपके बेसिक्स पे ही पूछ जाएंगे। बहुत कम ऐसे होते हैं जो कि बिल्कुल ही नया कंसेप्ट होता है। तो बेसिकली हमें काम करना चाहिए अपने कंसेप्ट्स पे, राइट, जो आपके मेन रेगुलर रूटीन कंसेप्ट्स हैं। जैसे हमने आज का टॉपिक एक पढ़ा कि सिक्रेशन के बारे में, फिर हमने एमसीक्यूज डिस्कस किए, तो इसमें कोई भी ऐसी चीज नहीं थी कि जो कि एकदम ही आउट ऑफ द बॉक्स आ रही है कुछ, राइट। आपने कोई सिंपल सी चीज पढ़ी, उससे रिलेटेड एमसीक्यूज है, तो अब ये एमसीक्यूज चाहे आपने पल्स से सॉल्व किए या कहीं और से सॉल्व किए, आपका कंसेप्ट स्ट्रांग हो गया, राइट, आपको कंसेप्ट याद हो गया, समझ में आ गया कि हाँ भाई पैरासिम्पैथेटिक सप्लाई है, या कौन सा सीरस है या कौन सा मिस्चीनस है, किस तरीके से कौन सा चीज काम करती है। तो बेसिकली वो बेसिक आपके जो है किसी भी टॉपिक के वो स्ट्रॉन्ग करने के लिए, चाहे आप पल्स पढ़ें, चाहे आप कोई और बुक पढ़ें, उससे आपका बेसिक कंसेप्ट जो है 90% ऑफ दिस सब्जेक्ट दैट विल बी डन विद दैट। जो 10% है वो कहीं का कहीं से भी आ सकता है, राइट। और रिसेंटली हमने क्या देखा है ना कि बुक्स में से बनने लगे हैं, बट इवन फ्रॉम द बुक्स ऐसा नहीं है ना कि कुछ भी नई सी चीज आ जाएगी, राइट। तो पल्स अभी भी रेलेवेंट है। आईना सीटी हो चाहे कोई सा भी हो, जैसे कि मैंने आपको समझाया, आपका जो मोटा मोटा कंसेप्ट है ना कि चाहे सलाइवरी ग्लैंड ले लो, अभी फॉर एग्जांपल जैसे जो भी कुछ हमने पढ़ा, हमने 10-12 क्वेश्चन सॉल्व किए, तो जो भी कुछ हमने पढ़ा वो 12 क्वेश्चंस ने कवर ऑलमोस्ट कर लिया, तो आपका रिवीजन हो गया। सेम चीज जब आप पल्स में देखोगे, किसी और बुक में देखोगे, तो आपका ज्यादातर टॉपिक वो कवर कर देंगे। और नया क्वेश्चन भी बना तो कैसे बन जाएगा, जैसे आज हमने एक नए क्वेश्चन का एक्सपेरिमेंट किया, मैंने आपको जब पढ़ते वक्त भी बताया था कि सोडियम क्लोराइड एब्जॉर्ब हो रहा है, वाटर एब्जॉर्ब नहीं हो रहा है, इम्परवियस है, और हमने उस एक छोटी सी नई इंफॉर्मेशन को लेकर के एमसीक्यू बनाया, राइट। तो इस तरीके के एमसीक्यूज आपके पास हैं जो कि आपकी पूरे सब्जेक्ट की प्रैक्टिस करवा देंगे, राइट। तो हो सकता है वो एग्जैक्ट एमसीक्यू ना आए, बट वो एमसीक्यू उसी इंफॉर्मेशन में से होगा, कोई नई इंफॉर्मेशन नहीं आ रही है ना। एग्जामिनर्स ट्रेंड नहीं फॉलो कर रहे हैं, तो ये तो अच्छी बात है ना, दिस इज गुड इफ द एग्जामिनर्स आर नॉट फॉलोइंग ट्रेंड। तो जिनकी भी थ्योरी स्ट्रांग है वो आराम से सॉल्व कर सकते हैं, इजंट इट, जिनकी भी थ्योरी स्ट्रांग है वो आराम से फॉलो कर सकते हैं। देखो क्या होता है, दो तरीके के बच्चे हैं, एक तो वो जो थ्योरी को ढंग से पढ़ रहे हैं, समझ रहे हैं, उनके कंसेप्ट स्ट्रांग है, दूसरे वो जो केवल रट के जा रहे हैं। अगर आप ये रट के चले गए कि मेरे पास ये एमसीक्यू आया, इसका मेरे को ये आंसर मार्क, सारे ऑप्शन सही है, सारे ऑप्शन सही है, पर हमें बेस्ट सिलेक्ट करना है, या सारे ऑप्शन गलत है, हमें उसमें से लीस्ट इनकरेक्ट वाला सिलेक्ट करना है, तो उन चीजों की ट्रेनिंग के लिए एमसीक्यू सॉल्व करना जरूरी है। ये बिल्कुल भी जरूरी नहीं है कि आपके यही एमसीक्यू उठ करके एग्जाम में है, ठीक है। इनफैक्ट ऐसा हो सकता है कि आप यहाँ सॉल्व कर रहे हो जिसमें केवल एक ही ऑप्शन करेक्ट है, और जब आप एग्जाम में जा रहे हो तो वहां पर एक से ज्यादा ऑप्शन करेक्ट आ रहे हैं, वो भी है। बट ऑल ऑफ दिस इज फॉर यू टू प्रैक्टिस, राइट, फॉर यू टू क्लियर योर कंसेप्ट्स। बेटा कुछ भी सजेशन मैं तुम्हें दूंगा तो इट वोंट बी, जो मैं तुम्हें अभी सजेशन दे रहा हूँ वही है, कोई सा भी एमसीक्यू पेपर उठा करके देख लो। आपको, आप अगर ये सोच के जाओ ना कि मैं इसमें से ऐसा कुछ पढ़ लूं कि मेरे पास उस 100 में से 90 क्वेश्चन मुझे यहाँ से मिल जाए, ऐसा नहीं होगा। हम एमसीक्यू इसलिए नहीं कर रहे हैं कि हमको यहाँ से 90 क्वेश्चन मिल जाए और वहां पर जाकर के हम उनका एज इट इज उतार दें, ठीक है ना। हम एमसीक्यूज क्यों कर रहे हैं, हमारी प्रैक्टिस के लिए, ताकि वो कंसेप्ट स्ट्रांग हो जाए, ताकि उस कंसेप्ट में से जब भी कोई एमसीक्यू आए कोई भी नया एमसीक्यू है हम उसे सॉल्व कर सकें, राइट। तो इंपॉर्टेंट बात क्या है कि कंसेप्ट क्लियर हो जाए, यही सबसे इंपॉर्टेंट पॉइंट है। इस वक्त जो सबसे इंपॉर्टेंट सजेशन है वो यही है कि अपने कंसेप्ट क्लियर करो, क्योंकि कंसेप्ट अगर आपके क्लियर है, अगर आपने किसी चीज को समझा है रटने की जगह, तो क्या होगा कि आपके पास भले ही उसमें से 10 नए क्वेश्चन आ जाए, यू कैन इजीली सॉल्व इट। प्रॉब्लम कहाँ आती है? प्रॉब्लम वहां आएगी कि सलाइवरी ग्लैंड्स में से कोई नया टॉपिक उठा लिया उन्होंने। हमने तो पढ़ा था सलाइवरी ग्लैंड की कॉम्पोजिशन पढ़ ली, हमने सलाइवा की कॉम्पोजिशन पढ़ ली, हमने बाकी सब चीजें पढ़ ली, लेकिन हमने ये तो पढ़ा ही नहीं कि सलाइवा की स्पेसिफिक ग्रेविटी कितनी है, ठीक है। और क्वेश्चन आ गया एग्जाम में सलाइवा की स्पेसिफिक ग्रेविटी बताओ, वहां हम अटकते हैं। तो वैसे क्वेश्चन कितने होंगे? 900 में से शायद 10 होंगे, 15 होंगे, बट वो सारे डिफिकल्ट क्वेश्चंस तो सभी के लिए डिफिकल्ट है। पर ये जो कंसेप्चुअल क्वेश्चंस हैं, जो आपकी थियरी में से हैं, जो मैक्सिमम पोर्शन कवर कर रहे हैं, ये आपके 80-90 क्वेश्चन इतने होंगे, राइट। तो आपके कंसेप्ट अगर क्लियर है, आपने भले ही वो एमसीक्यू सॉल्व नहीं किए हैं, यू स्टिल विल बी एबल टू सॉल्व दोस। आप एम्पावर्ड हो उन क्वेश्चन को सॉल्व करने के लिए, अगर आपके कंसेप्ट क्लियर है, राइट। तो पल्स या कुछ भी चीज आप इसलिए नहीं कर रहे हो कि आपको उसमें से क्वेश्चन मिलेंगे, वो आप इसलिए कर रहे हो कि आपकी प्रैक्टिस हो रही है। 60 मिनट्स के अंदर आपको 80 क्वेश्चन सॉल्व करने हैं, या आपको 3 आवर्स के अंदर 240 क्वेश्चन सॉल्व करने हैं, तो वो प्रैक्टिस के लिए हम पल्स कर रहे हैं, राइट। हम प्रैक्टिस कर रहे हैं उन वर्ड्स को पकड़ने के लिए, इनकरेक्ट, ऑल ऑफ द फॉलोइंग एक्सेप्ट, राइट, इस तरीके के वर्ड्स को पकड़ने के लिए, ठीक है। और क्या डाउट है वो बताओ। तो ये मत सोचो कि मैं तुम्हें ऐसा कोई जगह बता सकता हूँ कि जहां से तुम्हें 100 में से 80 क्वेश्चन मिल जाएंगे, ऐसा नहीं होगा, ठीक है ना। वो पहले हुआ करता था कि आपने पढ़ लिया पल्स, या आपने प्रीवियस ईयर्स के कोई पेपर्स पढ़ लिए, या आपने एसआरशिप के पेपर पढ़ लिए और आपको बहुत सारे एमसीक्यूज मिल गए। अब नहीं होता ऐसा। तो बेस्ट तरीका ये है कि आप अपने कंसेप्ट्स पे काम करें, राइट। ट्राई टू अंडरस्टैंड दी थिंग्स, नॉट क्रैम देम। और कुछ पूछना है आपको? 2 साल से 2000 रैंक आ रहा है, आगे नहीं जा रहा है नीट के रैंक। तो बेटा सबसे पहले तो ये हमें आइडेंटिफाई करना चाहिए कि प्रॉब्लम कहाँ आ रही है, ठीक है। अगर हम क्वेश्चंस को ढंग से समझ पा रहे हैं या नहीं, क्या हमारे पास टाइम मैनेजमेंट ठीक से हो रहा है, तो वेरी गुड। पर जो मैं बता रहा हूँ उसको भी थोड़ा सा ध्यान रखो, है ना। अगर आपकी रैंक इंप्रूव नहीं हो रही है, तो हमें एनालिसिस की जरूरत है, सेल्फ एनालिसिस की सबसे पहले, ठीक है ना, कि हमारी गलती कहाँ कहाँ हो रही है। हमने जैसे कि मैंने बताया टाइम मैनेजमेंट सबसे पहला, उसके बाद कंसेप्चुअल प्रॉब्लम्स, या क्या हम बार बार सेम मिस्टेक्स रिपीट कर रहे हैं। सेम मिस्टेक्स कैसे? कि हमने कोई क्वेश्चन पढ़ा, क्वेश्चन पढ़ने के बाद हम एकदम इम्पल्सिवली उसको आंसर कर देते हैं। तो कई बार क्या होता है, हमें पढ़ने के बाद ऑप्शंस को ढंग से देखना जरूरी है, राइट। जैसे अगर हम पीछे, मैं बार बार एक ही पे इसलिए जा रहा हूँ क्योंकि यहाँ पर मैंने एक अलग सा क्वेश्चन इंक्लूड किया था, राइट। तो तुम सोच रहे हो कि मैं बार बार एक पे जा रहा हूँ, बट क्या करें, ये बेस्ट एग्जाम्पल है अभी आज के हमारे केस में, राइट। तो जैसे कि हम इसकी बात करें, अगर मैं ऑप्शन डी दे देता नन ऑफ दी अबव, राइट, तो क्या होता कि हम इम्पल्सिवली नन ऑफ दी अबव मार्क कर देते, क्योंकि ना सोडियम दिख रहा है ना क्लोराइड दिख रहा है, हमें कुछ भी नहीं दिख रहा। तो आपको फिर ये भी सोचने की जरूरत है कि क्या हम इम्पल्सिवली मार्किंग तो नहीं कर रहे, क्या हम ऑप्शंस को ढंग से पढ़ रहे हैं, समझ रहे हैं, ऐसा हम कर रहे हैं कि नहीं। देखो आधी बैटल वही हम जीत लेते हैं जब हम क्वेश्चन को ढंग से पढ़ लेते हैं। कोई भी क्वेश्चन इजी या हार्ड तब है कि जब हमने उसके क्वेश्चन को ढंग से समझा है या नहीं समझा। अगर आपने समझ लिया तो क्वेश्चन आसान हो गया, राइट। तो आप आधी लड़ाई तो वहीं जीत गए। फिर बात सिर्फ ऑप्शंस की रह जाती है, यूजुअली यू विल बी एबल टू आइडेंटिफाई द करेक्ट ऑप्शन। तो सबसे पहली मिस्टेक जो हमारी होती है क्वेश्चन को समझने में हो जाती है, हम क्वेश्चन को ही ढंग से नहीं समझ पाते। तो आराम से अपना टाइम लो, क्वेश्चन को टाइम दो, ठीक है ना। क्वेश्चन को ढंग से समझो कि वो क्या पूछना चाह रहा है हमसे, देन थिंक इन योर सेल्फ कि ये हमसे क्या पूछना चाह रहा है और उसका क्या करेक्ट आंसर होना चाहिए। फिर आप ऑप्शन से मैच करो, उससे मिलता जुलता कुछ है या वही एग्जैक्ट चीज है, तो दैट इज योर बेस्ट ऑप्शन, ठीक है। अगर आपको ऐसे समझ में नहीं आ रहा, आप उसको अपनी लैंग्वेज में ट्रांसलेट कर सकते हो, आप उसको हिंदी में समझो। जैसे मुझसे पूछ रहा है विच ऑफ द फॉलोइंग मैसेज मींस व्हाई मैं, तो मुझे नहीं समझ में आया, तो मैंने अच्छा सलाइवा हाइपोटोनिक क्यों होता है, ये तो मुझे समझ में आ रहा है, तो हम उसको ट्रांसलेट कर सकते हैं, ठीक है ना। हम ये देख सकते हैं अच्छा पानी वापस से एब्जॉर्ब नहीं होगा तो हाइपोटोनिक ही होगा, है ना। तो हम इस तरीके से उसको ट्रांसलेट कर सकते हैं। हम ये देख सकते हैं कि और कुछ ऐसा कैच वर्ड तो नहीं है कि हमने कोई कैच वर्ड तो मिस नहीं कर दिया। तो उसी के लिए ट्रेनिंग की जरूरत है, जो हम बार बार एमसीक्यू सॉल्व करते हैं। तो इस तरीके से आइडेंटिफाई करो कि तुम्हारी प्रॉब्लम्स कहाँ रह रही है, कहाँ पर कमी आ रही है, बार बार क्यों हमारी रैंक वहीं अटकी हुई है, जबकि आपने डेफिनेटली 2 साल पढ़ रहे हो तो आपने प्रोग्रेस किया है। तो फिर रैंक क्यों अटकी, क्योंकि कहीं ना कहीं हमारी टेक्निक में गड़बड़ हो रही है जो हम एमसीक्यू सॉल्व कर रहे हैं। तो वो टेक्निक को इम्प्रूव करना जरूरी है बेटा। और टेक्निक कैसे इम्प्रूव होगी, एक तो कंसेप्ट क्लियर करो अपने, दूसरा मैक्सिमम एमसीक्यूज जितने सॉल्व कर सकते हो करो, ठीक है। और फिर उनका एनालिसिस करो कि जो बार बार गलतियां हो रही है, रिपीटेड मिस्टेक्स हो रही है, वो क्यों हो रही है, ठीक। फिर भी कोई डाउट हो तो वापस मुझसे बात करो। और कुछ? और कोई डाउट? तो आई होप अब और किसी को भी डाउट नहीं है। चलो ठीक है ना, सॉल्व करो एमसीक्यू। देखो अभी फ्रेश है अपने ये सलाइवरी ग्लैंड्स के बारे में थोड़ा बहुत पढ़ा है, अभी हम फ्रेश है। तो कोशिश करो थोड़े बहुत अभी जो भी कुछ हमने पढ़ा है इसके ऊपर एमसीक्यू सॉल्व करने का, है ना, ताकि ये कंसेप्ट तो कम से कम एकदम पक्के हो जाए अपने। चलो ऑल दी बेस्ट एंड गुड नाइट।